Question 4 says, use the ratio test to determine whether each series converges or diverges. For part A, we're looking at the sum of 3 to the n over n factorial, and n starts here at 1. And so to apply the ratio test, we're going to start by looking at this ratio, right, which is a sub n plus 1 divided by a sub n. And here a sub n is 3 to the n over n factorial, and so a sub n plus 1 is 3 to the n plus 1 divided by n plus 1 factorial. Okay, now to compute this ratio, I'm going to go ahead and take a sub n plus 1, which is what you see here in green, and I'm going to multiply it by the reciprocal of a sub n, right? So division is equivalent to multiplying by the reciprocal. And the nice thing about doing it this way is that the simplification steps are just going to be a little bit easier for us. Okay, so let's go ahead and simplify. 3 to the n plus 1 divided by 3 to the n. Well, we're going to lose n factors of 3, just leaving 1 remaining. So that's going to simplify to 3. And then n factorial over n plus 1 factorial. Okay, as we've seen now a few times, right, the product of 1 through n divides out, and we get 1 over n plus 1. Also note that since a sub n is positive for all n, I can drop the absolute value, and so this ratio in absolute value is equal to 3 over n plus 1. And r, which is the limit of this expression, is then 0. And since r is less than 1, this series converges by the ratio test. All right, great. Let's check out part B next. So here we're looking at the sum of negative 2 to the k over k squared, and k starts at 3. And so we'll start out in just the same way. A sub k is negative 2 to the k over k squared. And so a sub k plus 1 is negative 2 to the k plus 1 divided by the quantity k plus 1 squared. And again, just as in part A, to compute the ratio, I'll take a sub k plus 1, which you see here in green, and I'm going to multiply it by the reciprocal of a sub k. And now we can go ahead and simplify. Negative 2 to the k plus 1 divided by negative 2 to the k. We lose k factors of negative 2, leaving 1 remaining, so that simplifies to negative 2. Then for k squared over k plus 1 quantity squared, I'm going to simplify that over here. First note that the numerator and denominator are both squares, and so I can write that as k over k plus 1 quantity squared. And now thinking ahead, I know I'm going to have to take the limit of this expression as k approaches infinity, and since I have a k in the numerator and denominator, I'm going to go ahead and divide the numerator and denominator by k. And so this then is equal to 1 over 1 plus 1 over k quantity squared. And so that goes in right there. Note a sub k in this case takes on both positive and negative values, so the absolute value is necessary. And I can remove the absolute value by just replacing the negative 2 with a 2. And so here I see that the value of r, which is the limit of this expression, is equal to 2 in this case, right? Again, and the nice thing about writing the k squared over k plus 1 quantity squared in this form is that it makes it very clear what's happening in the limit. 1 over k goes to 0, so this becomes 2 times 1 squared, which is 2. All right, cool. And so in this case, since r is greater than 1, the ratio test implies that this series diverges. All right, so let's go ahead now and check out part C. Okay, so for C, we're looking at the sum of 2 to the n times n factorial all over 2n factorial. Okay, so here we got a sub n is 2 to the n times n factorial over 2n factorial, and so a sub n plus 1 is 2 to the n plus 1 times n plus 1 factorial divided by, and then here I have 2 times the quantity n plus 1, and then here we have this factorial. Okay, now in this next expression, I've just distributed the 2, so I get 2n plus 2 factorial. All right, so I'm going to take a sub n plus 1 and multiply it by the reciprocal of a sub n, and then we're going to simplify. So 2 to the n plus 1 divided by 2 to the n, well, that's just 2. N plus 1 factorial divided by n factorial, okay, that's just going to give us an n plus 1. and then for the 2n factorial divided by the 2n plus 2 factorial. I've simplified that over here. So you've got to be a little bit careful. So for the numerator, I have the product 1 times 2 times 3 all the way up to 2n. Now for the denominator, 2n plus 2 factorial, I'm going to have that same product, 1 times 2 times 3 up to 2n. But then since 2n plus 2 is 2 more than 2n, okay, I'm going to have these two additional factors in this case, right? The quantity 2n plus 1 times the quantity 2n plus 2. So we go ahead and divide, and we get, for our denominator here, 2n plus 1 times 2n plus 2. Also note that since a sub n is positive for all n, I've dropped the absolute value. All right, great. So now note that 2 times the quantity n plus 1 that you see up here in the numerator, okay, that's really just 2n plus 2, and I have a 2n plus 2 down here, so I can divide those out, and so I see that this ratio in absolute value is equal to 1 over 2n plus 1, and so our value for r in this case is equal to 0. Since r is less than 1, ratio test then implies that this series converges. All right, great. So then, pressing on to the last part, this is D, we have the sum of 2n plus 3 over 2n plus 7. All right, so we start out in just the same way. A sub n is 2n plus 3 over 2n plus 7. A sub n plus 1 is then 2 times the quantity n plus 1 plus 3 over 2 times the quantity n plus 1 plus 7. And then we can simplify that to 2n plus 5 over 2n plus 9. And so now, to compute the ratio, take a sub n plus 1 and multiply it by the reciprocal of a sub n. And now while it might be tempting to multiply these expressions out, okay, remember we're going to take the limit of this thing. And so if I look at just the green expression, as n gets big, since I have a 2n here in the numerator and in the denominator, okay, this is going to approach 1. And likewise for the blue expression. To make that a little bit more precise, okay, I'm going to go ahead and divide the numerator and denominator for both the green expression and for the blue expression by n. And I'm going to write the whole thing in this form. Also, I can drop absolute value because a sub n is positive for all n. And now we go ahead and take the limit, and we can see here that r is going to equal 1 in this case. Okay, so as we noted in the last video, if r is 1, okay, ratio test is actually inconclusive. Okay, it does not tell us whether or not this series converges or diverges, so we have to try something else here. Right, now this is a lot of work to run into a dead end. Okay, so a little bit later, we're going to discuss strategies for which convergence test to apply when, because we would like to avoid running into those kinds of dead ends. Okay, so as another approach, let's let a sub n, right, just note that this thing is going to approach 1 as n approaches infinity, right? A sub n is 2n plus 3 over 2n plus 7. Since I see a 2n in the numerator and denominator, I'll go ahead and just divide numerator and denominator by n. And so I can see, yeah, a sub n is approaching 1 as n approaches infinity. So in particular, since a sub n is not approaching 0 as n approaches infinity, this series diverges by the test for divergence, right? This is a heck of a lot simpler. All right, great. Well, that's going to do it for this video. In the next video, we'll look at another example where we use the ratio test. Thanks so much.